Hello, friends of .NET.
Hello, welcome to the Languages and Runtime.
Yeah, go ahead.
All right, sorry about that. Even I didn't have lined up who was going to say hello. We both say hello. Welcome to the Languages and Runtime Community Stand-Up today. And I'm Kathleen Dollard, and I'm here with these great folks. We'll be talking about MSBuild, and then we're also going to pull in Jared Parsons to talk about a recent change in the C# language that some people have been questioning a little bit, and we want to talk about why we got to where we are. So that's the two topics for today. To introduce everyone else, I'll start with Immo.
Yeah, my name is Immo Landwerth. I'm a PM on the .NET team. And then I think next is Chet.
Chet, yeah.
Hi, everybody. I'm Chet Husk. I'm a PM on the .NET SDK, MSBuild, and templating engine teams.
And I'm Rainer Sigwald. I'm a dev on that same team, spending most of my time on MSBuild.
All right. Well, the focus for the first 45 minutes will be MSBuild. And please ask any questions in the chat. And even if it's on something else, we'll try to go there. And then, again, in about quarter till 11 Pacific time, we're going to bring in Jared Parsons, and we're going to switch gears and talk about this C# language change, because it's been getting a little bit of conversation on Twitter. So we wanted to respect that and have a conversation about it today. So that's where we're at. So I don't know, can we start by just placing MSBuild in the developer experience for the Microsoft ecosystem, either Chet or Rainer?
Oh, wow. MSBuild is central to the developer experience in the .NET ecosystem. It drives so many interactions that people have with their projects, with others' code. It is the beating heart at all of that, at the center of all of that. Every time you run .NET Build on the command line, or every time you click Build in Visual Studio, you're using MSBuild to orchestrate everything that happens, from package acquisition to compilation, to optimization, to launching the executable. It's all MSBuild in the end, friends.
Okay. So what MSBuild looks like to me as a developer. Now that's my CS project file, VB project file, or FS project file. So that's how I give information to that. And that's like a really short little file right now. I mean, it doesn't really look like it does very much. And you're telling me not only does it do things like when I say .NET Build, that it also has these other roles. So, so tell me what happens when my little tiny file that I can understand turns into a whole bunch of stuff I know nothing about.
Yeah, absolutely. So the thing that I like to tell people about the build, not to scare anybody off, but just to understand, is that like a lot of things, it's complex behind the scenes, and sometimes the abstractions leak, and you have to deal with some of those details behind the scenes. Um, so the first thing that MSBuild does when it starts to build is it loads up that project file, which is a few lines of XML. But one of those lines in a modern project file, especially for a .NET 6, a brand new project, is going to say project SDK equals. And then in that, there'll be a name that talks about an SDK. Usually it's Microsoft.NET.SDK. And that is going to go and import a bunch of build logic behind the scenes, defaults for things like, for instance, what files do you want to feed to the compiler? Probably everything in your directory that ends with .cs in a CS proj or .vb in a Visual Basic project. You can tweak those by setting properties and items in your own project. And then it's going to define a bunch of targets, like a bunch of stuff. Build, how do we run the compiler? How do we make sure that we have all the NuGet packages that we need? What do we use from those NuGet packages? What assemblies are we going to reference? Do they have build logic that we need to pull in? And all of that gets dynamically figured out at build time and then executed in the right order, unless there's a bug. Sometimes it happens. And then at the end, you get your executable out, you get log messages, and the side effects from the perspective of the build system are the code that you actually care about running.
All right. Okay. So we actually got a question in the chat that I think we're working on answering, which is, how does it work in simple terms? And I think what you just walked through with these, we start with a small file. This SDK line at the top is really critical because it tells us what the other junk stuff, to bring in is going to be. And then we're talking about properties and targets. And can you talk a little bit more about what those actually are? So I don't actually, do I see them in my project file? Is this something that's going to I directly touch, or is this just some behind the scenes thing? And so how does that all work?
Yeah, absolutely. So I've got some projects we could play with a little bit here if you want to show my screen.
I will absolutely do that. Let's try this format right here.
Okay. So let's see. So I've got here a small project file. It uses the web SDK. And it defines a few things that are not always obvious that we can't infer reasonable defaults for. For instance, what target framework are you building for? Here we got Net 6.0. And this is a project that I created brand new from templates. So it turns on some of the cool new features in the C# language. So we got nullable analysis turned on. We've got implicit usings turned on for this particular project. And these are defined, they're in a property group, which means they become MSBuild properties. And you can think of an MSBuild property as just a string, a variable of type string.
And that's a global variable, right?
Within the project, it's global, and it's something that you can change and modify.
So if I have multiple projects in a solution, it's not global across the different projects. That each need their own properties to be defined, but within that one project, everything that happens is going to use this set of properties.
That's right. So it's totally fine to have a solution that has some projects that target, for example, Net 6.0, and some projects that target Net Standard 2.0, perhaps. Okay. That's all totally fine. And those each get to live in their own little world of the project. You can even have a project that multi-targets when you use target framework with an S here and specify more than one. And we'll actually talk about that a little bit later when we start digging into what does a build do. So another thing you can see here is a thing that's very common in projects where you have a package reference, and you can add those using the Visual Studio IDE. You can add those using .NET CLI commands like .NET add package. And here, so I've got everyone's favorite NuGet package, Newtonsoft.json, and it's defined here in an item group. That's different from a property group. Items in MSBuild are similar, but different from properties. Specifically, items are lists of things. So you can have a bunch of package reference items. So for example, if I do, I can't think of a great example to add right now, but if I add another one, I'll get another line that says package reference include equals, and then something different here. So those are the two core data types in MSBuild: properties, which are basically string variables, and items, which are this list variable.
Yeah. Do you want to just close out your team?
Yeah. Let me get rid of this.
Yeah.
All right.
Sorry. I was saying we try to close teams, and that came up on the on that. So yeah, sorry for that distraction, folks. That's totally my bad. I thought it was a good idea to use that for us to talk to each other, but yeah. Yeah.
So again, like we talked about, hey, this is fairly understandable. You can get a flavor of what's going on from all this. But what the build is much more complicated than just what you see here. So we can use an MSBuild feature, the preprocessor, to actually expand all that build logic that gets imported from this SDK. And let's do that just a little bit. So .NET MSBuild-pp, and that'll spit it out to standard out. And I'm just gonna you'll see why in a second, but I'm gonna go ahead and pipe this to word count lines, and we'll go in and we'll consume all that. And you can see why I didn't actually show it, because this project is, again, it's deceptively simple. There are actually 18,000 lines.
Whoa! Oh my gosh, that's crazy.
Working behind the scenes to get you the experience that you want to build.
Okay, so that is like, oh my gosh. Okay, so let's unwind a couple of things here. So I have a couple of questions. Okay, so first of all, and then I want to get back and I want to go deeper into this, but I want us to just do a couple things first. Okay. So first of all, you said .NET build earlier. You said it also ran in Visual Studio. Now, is that just when I do a Visual Studio build, or does it also affect the design time experience and all those analyzers and stuff? Is that part of what's going on in this? We got to set the world up with 18,000 lines of code?
Yes, absolutely. So in addition to running your build, when you build on the command line with MSBuild.exe or with .NET Build, Visual Studio and Visual Studio Code, when you use the C# extension to get the full IntelliSense experience in Visual Studio Code, all of those use MSBuild behind the scenes to understand what the project is like. All
right.
And that helps coordinate everything and get everything together. And so that enables you to get the IntelliSense that works the way that you hope it does in Visual Studio, and gives you the right squiggles that correspond to what happens when you do an actual build. You could build the systems totally separately, but then you would have much more drift where things look like they're working in the IDE, and then you drop to the command line to do a build and it doesn't work. That's a terrible experience for everyone. So let's use MSBuild for that everywhere.
All right. Okay, then we had a question about resources for MSBuild, and I think that Immo set up a banner for us. So so do we have the resources that came up? There we go. That's what I was looking for. Okay, so Microsoft Docs, it's come a long way. So check it out. The MSBuild stuff there is good. Then there's some other resources you can jump off from there on. It's an interesting thing, because in one perspective, of course, you kind of want an understanding of this. On the other hand, I'm just going to guess very few people want to understand this 18,000 lines of code. Rainer, I'm not even sure you do. So, that is incredible. And so that's where I want to go. At first, I've been talking so much, and I want to let Immo and Chuck get in here with anything that they want to add. And then let's find out what we're going to do. I mean, how do we even cope? How do we begin to cope? So, yeah, but before we do that, what you got, Immo? Anything?
You mean question-wise?
Yeah,
I think
or
most. Yeah. One of the questions that I had, I start with my favorite question, which is my own, obviously. So can you briefly say about the differences between MSBuild, .NET Build, and .NET MSBuild?
Yes,
Yeah.
absolutely. Um, so MSBuild is a piece of code that is fairly old. It's been the build system for C# projects in Visual Studio for a very long time. It was actually part of .NET Framework 2.0 is when the first version of MSBuild was released. And it's existed for a long time. It's got an API that you can build, and it's got a command line interface, msbuild.exe. And that comes either an old copy of it comes with the .NET Framework, but modern copies of it come with Visual Studio, or on a build server or something like that, you might install them with Visual Studio build tools instead of the full Visual Studio UI experience. .NET Build comes with a .NET SDK, and it's that .NET.exe command line, or if you're a Unixy person, .NET.nothing, because there's no extensions. And it uses MSBuild to do its build operations, but it provides a convenience wrapper for you. So you can do .NET MSBuild, and that's roughly very similar to calling msbuild.exe in the command line. If you do .NET Build, that's almost exactly the same as doing .NET MSBuild with the -restore option, which will restore all your NuGet packages before you build. And so both of those are implementations of MSBuild. They're built from the same code base. So we were talking earlier about building a multi-targeting project that has 2 different target frameworks in the same project. We do that in MSBuild itself. So msbuild.exe and Visual Studio run on the .NET Framework version of MSBuild. .NET Build, .NET MSBuild uses the .NET 5 or .NET 6 version of MSBuild. And but they're very similar. There are some capability differences, and of course, over time, we're trying to make the .NET Core version more capable and hopefully able to build all projects. Right now, there are some project types, especially around C++ and certain other SDKs that are not core .NET 6 ecosystem things that you can only successfully build in msbuild.exe.
Okay, so but to answer Immo's question around that, yes, I thanks for going deeper into that. But .NET Build, .NET MSBuild, and MSBuild.exe are all ultimately MSBuild, and they might be the .NET Core version, and they might be the framework version, depending on which one you've got there. So that's great. So I think that answers some of the questions we were getting from Dustin in the chat about the relationship. So if you want to dig deeper that, and the other thing that came up in the chat here is that Syed Hashimi's book, which is actually getting kind of old, but it is a really good reference because MSBuild doesn't change. Now, the one thing I'd add to that is that if you look at that book, it's big, it's thick. It's for wanting to understand more about what's behind MSBuild. If you just want to get your job done, you do not need to read that book. Parts of that book may be helpful to you, but it's a deep dive where you may not need. You can show that to us again, Chet, so everybody can. So show us how thick it is, right? Okay, you do not need to read that whole book, but yeah. So
yeah,
Chet,
definitely. I would show you my copy, but I can't reach it with my headphones plugged in.
Yeah. So Chet, did you have anything to add?
Yeah, I just wanted to call out that off of that first link, that Microsoft Docs link, you get sort of the high level conceptual overview of what MSBuild or how MSBuild operates. There are some deeper dives into specific concepts that Rainer mentioned, like items and properties and globbing and how those things work. So I would really suggest those documentation pages as your first starting point. And then when you really want to go deep, consider the book, consider some of the other things we're going to talk about later in the program today.
And about that documentation, like all Microsoft documentation, we welcome feedback. We would love to know things that are unclear, things that you wish there were docs written on specific areas. Please let us know those things because we want to make that a great experience for everybody.
I thought one question that was interesting is like, does MSBuild compile or link our code? I think that might be a good high-level overview of what MSBuild actually does.
Yeah, so MSBuild is a build system in the very classic sense. So the other ones that you may have used include GNU Make, and there's various different tools in other ecosystems. But MSBuild is a system that can run tools, and it can either run command line tools like csc.exe and construct a command line for that and run that tool. There's a way you can also build what's an MSBuild task, which is a way of kind of short-circuiting some of that. So if you have some .NET code, MSBuild is a .NET application, you can run your .NET code just inside the MSBuild process to accomplish the same kinds of things right there. But MSBuild itself doesn't know much about C#, doesn't know much about Visual Basic or F# or C++, but can be used to build a build system for any of those things and other things that are, as long as you can describe the tools that need to run and the transformations that need to happen to get from the source code in your repo to the output that you want, you can express that in MSBuild. It's fairly general purpose, but realistically, people mostly use it for Visual Studio projects and .NET projects in all environments.
Yeah, that makes sense.
So,
All right, I think that's kind of the core questions, I think. I mean, there's some more advanced questions which we may want to just answer directly in chat so we don't derail entirely.
I also there's a good shout out to Genevieve, and I want to say, yes, we've done some investment around this, and Genevieve Warren, who did that, is awesome. And yeah, it's the docs are pretty good. So, we always think they can be better, but they're pretty good. So, yeah. All right. Well, I don't know, Rainer, where should we go next?
Well, so
where should we dive into next?
So far, we've talked about how the build is real complex, and hopefully you don't have to worry about it. But sometimes things go wrong. You get errors, and those can be extra fun types of errors. Like everything works on my machine, but in CI or the PR build, something is failing and it's confusing, and I don't exactly understand what's going wrong. So there's this kind of big question. Okay, well, what do I do about that? MSBuild has had, since the very beginning, the ability to have logging infrastructure attached to it, just like you would have logging infrastructure attached to any kind of live operations problem. An ASP.NET website, you're going to have some logging that you can figure out what's going on. And we have some new developments in MSBuild logging. Not super new. This is not brand new off the press. Hopefully, the basics of this should work in any version of MSBuild that you come across. And that's called the binary logger. So I'm here. Let's go ahead and just build this project. So I'll just do .NET build -BL for binary logger. So that means attach a binary logger to the build of this project, and we'll go with it. You get a little information. We're going to restore. We're going to go along. We're going to complete the build. It took a few seconds. Everything's looking good. So what that did is it spit out a msbuild.binlog file. You can also specify a specific name for that file. This is the default. So I'm going to go ahead and do something here. So what can you do with that binlog file, and what is inside it? And the answer is all the answers to all your problems. Hopefully, probably not actually everything, but there's a ton of useful information in there. So one thing that you can do with that file is you can replay it, which means you can create a text file that is the logging that has existed in MSBuild since the very beginning. So you can do that by passing that binlog file as a project file to MSBuild. So instead of building .csproj, you build the binlog. So MSBuild, and then MSBuild.binlog. And I'm going to say no console log and file log at diagnostic verbosity. That's going to go and it's going to play. Now, if we look, we have two files here. We have msbuild.binlog and msbuild.log. This is the textual representation of the file. This is what we just replayed. And you'll notice when you look at the sizes here that there is a bit of a difference. The bin log is 400K for this project, and the text log is 7 megabytes. That can be even more dramatic if you look at other projects, like Orchard Core is a popular open source .NET project. It is a CMS system. There you get a 36 megabyte bin log, but the text log is 2.7 gigs. And this is the beauty of compression technologies. And also we've improved some of this logging. We're able to log strings only once when that's relevant. So we can just open up that text log in Notepad or your favorite editor. And one thing that you might notice here is some of these paths look a little fishy if you're a Windows person. And that's because I did a little sneaky thing. I was building in WSL window, and then I exited it to get back to Windows. The bin log format, it does not care about architecture, runtime. You can deal with those logs from anywhere and move forward.
And let's remind people what WSL is, because that may not be there for everybody. That's the Windows system for Linux. So it's a Linux build we're looking at on Windows, which is like, it's the world we live in, but it still kind of blows my mind when we do stuff like that. So go ahead. I want to make sure that people understood the impact of the forward and back slashes was the funny part.
Yeah, absolutely. And then so let's so that's great. So we've got a binary log. We can replay it to a text log. That is good, but maybe not the most exciting thing you've ever seen. Enter an open source project run by Kirill Osenkov, who's a dev at Microsoft, that is going to that has really helped a lot of people understand what's going on in their build. And that is the binary log viewer. So I think we have a banner for the MSBuildlog.com. So I have the viewer installed on my machine, so I'm going to just open this up. So here we have, wonder of wonders, a UI application that understands that binary log format and can present it in a way that's a little bit nicer than scrolling through tens of thousands of lines of text.
A little. Yeah. So wait a minute, the whole tens of thousands of lines is behind this?
Yeah. So we looked here, and we have this bin log that's 400K.
Okay.
And that actually has more information than the text log that we replayed out of it.
Wow. Okay.
Even though the size is very different.
Yeah.
And it's basically all of that is rendered here in this UI so that you can see almost everything that's going on in a fairly clear way. Now, the bin log is awesome because it gives you a single file that you can send to a colleague, that you can look at yourself, that you can store over time, that you can generate in your PR or CI builds in case something is happening in that case where it's like it works on my machine, but it's failing in CI, that sort of thing. But you do want to think before you share these logs. And let me show you a little bit about why. They have all your project files in it. So if you share a log that has like deathray.csproj, people might know what you're working on in your secret basement lab, right? If you share a project file inside that, we can see lots of things like inside this project, you can see imports. If you look in the files tab here, you'll actually see all of the files that are imported. This is not all of the source files. So you're not shipping your C# or VB source as part of the log files, but you're shipping all of the MSBuild logic. So you see things like the actual CSproj itself is there. Imported files like these ones that are generated by NuGet are there. Things that affect your repo are there. So again, it can potentially has stuff that you don't want everybody to know about if you've got, deathstar.csproj. So be aware of that. We've also got things, so you can search in this log. There's a great system here. So you can search for a bunch of the different things. So This is a C# project, so we might be interested in what is the compiler actually doing. So we can say task CSC, and we can find that that's happening in a target named core compile, and here's the task. And we can see, I'm going to close these because in presentation mode, it's kind of hard to have them side by side. Here are all the parameters that were passed to the CSC task, and it includes things like here's the sources files. It was program.cs, and this was a MVC project, so it's got some controllers, some models. It's got these global usings because we opted into those at the project file level. And so you can already see how you can extract information from this log to understand what the build was doing. We saw in the log before that we were opting into global implicit usings, and here we've got we see that a file named global usings was pulled into the compilation. And you can see things like constants that are defined. So if you're defining a constant, even if it's not in your project, even if it's not in your project file and everything's okay, but you're defining a constant that's like enable whatever that you don't want people to know about, it's going to be in the bin log. So think about it. The other thing that you got to keep an eye out on is environment variables, because if you have secrets in your environment variables, you definitely want to make sure you're not sending those out to other folks.
Rainer, some of your secrets just spilled out here. We can tell you're a Rust aficionado. I see
Indeed.
that cargo bin in there.
Yep, I have been running Rust in the same WSL virtual machine. So,
do you have any hints about how people can clean up their bin logs to make them safe to send? Is it hopeless, or are there things people can do?
There's not a great answer today. That's something that we would like to look at in the future. So today you need to check, and if there's things like environment variables that aren't critical to your build, you can always start a new environment, explicitly unset those variables, run your build. And that's the best practice. So the best practice, for example, in CI is like, don't have any of those secrets available to your build. Have those in a separate step or a separate job,
right.
In order to do your publish to whatever, things like that.
Right. So if folks are interested in seeing us work on something that makes it easier to clean those up, then reaching out to Chet or reaching out on an issue in the repo or something like that would be great. And we also had a similar question to the one that Immo just posted. I think on Mac. I think that was how to replicate this on Mac. So that's a really good question, because what you just saw was a WinForms application. So yeah.
So there's actually there are two very good pathways for working with bin logs on non-Windows systems. And one is a standalone application, just like Rainer was just using. There's an Avalonia-backed build of the structured bin log viewer that works on Mac OS. I'm not sure about Linux. I haven't personally used that. But at my previous job, I used the Avalonia build on my Mac box, and it worked wonderfully. There is also, as Rainer is showing now, a standalone web application that lets you open those same bin logs.
And this is using some of our cool .NET technologies like WebAssembly in the browser to run very similar code to what was running in that WPF application on my desktop, running in the browser here.
All right,
Rainer,
great.
do you know if this is a self-contained application, like only client-side WASM, or is there a network component?
Yeah, absolutely. So you can drag and drop a bin log in here. That is not uploading it to the cloud and processing it anywhere else. It's something that happens in your browser that you can keep a hold of.
All right.
And again, the bin log itself is cross-platform. So you also have the option of share that bin log to yourself using your favorite technology and open it on a Windows machine if you have one handy.
Oh, okay. So the build fails on a Linux machine, but I just bring that over and put it on my Windows machine or my whatever. I mean, I get a Windows VM open or do whatever I need to do in order to use this tool. So so if people are looking at these big files, is there a performance hit of the web one, or are they pretty comparable?
that's something that you're definitely going to have a better experience with the native application or with the local application. The web experience was very, very painful for a while, and now is dramatically better. But it is not exactly the same performance level as the.
Yeah. And just to follow up on something Dustin said in the chat, which is we did not do this web side of things until we had WebAssembly, so that we could keep your log files local, and your log file does not leave your machine when you use the web version, which of course is critical to actually making this work. So yeah.
Absolutely.
Well, I want to say just a couple things real quick about all these applications that we've seen here. They're all built on top of a structured log library that Kirill made as part of this tool as well. So I've seen some questions in the chat about, can this be integrated into my CI system? That library is your tool for doing that. It's very easy. A couple weekends ago, I did something along these lines. I used the structured build library to load structured binary logs and poke into these data points here. So that environments folder that you see there is available in that library, and you could apply any sort of validations or customizations that you wanted through that library.
Yes. So, and that's definitely a popular choice. Another option that you have is one that I used here, which is replaying the log, and you can attach an arbitrary logger. So that loggers have been extensible in MSBuild for a very long time. You can write a logger DLL and associate it with the build. So if you have an existing logger that you want to use, you can extract information from bin logs by replaying it using your logger. And a lot of times when you do that, you want to flip that no console log switch so you don't see a ton of text in addition to the thing that you actually care about from the default console logger.
That hurts my head just a little bit, but I think I'm with you. So yeah.
So one other question that we got here that might be relevant to this whole thing is this one here. Is there, like, this is a log viewer, right? But is there a way to actually step through MSBuild?
Yeah, so this is an interesting question. So there was an attempt many years ago to build a debugger that would work in Visual Studio. It never got fully productized. So there was some code in MSBuild that you had to only turn itself on if you set a secret environment variable that wasn't documented and then did some other things. And it was never fully high fidelity. Like I personally played with it and was never able to get it to work all the way. And we've really invested in this type of build diagnosability, which is this kind of after the fact logging and analysis over the debugger in the recent few years. Some of that is that's kind of my philosophy. My philosophy is you have to have the logs, because you're not going to go debug it on your CI machine as it's building if it's failing only there. So you need logs, and you need to be able to understand what's going on in those logs. And I think you should treat your build operations as an operations problem. You need logs. You need to be able to collect those logs. You need to be able to deal with those logs. There is continual interest in, should we do something different? Should we bring back a debugger? There are definitely cases when it would be nice to be able to step through a target and see what's going on in individual tasks and what the state of the world is at any individual time. We're not totally opposed to that, but recently we've definitely been investing in this kind of offline analysis approach.
So if I can take a stab at that from the PM perspective as well, something I'm very interested in is broader language services support for MSBuild in Visual Studio, VS for Mac, all of the editors that Microsoft supports, right? I view debugging project files and debugging your build as part of that language services thing. So if those sorts of capabilities are things that you want or you would use in your day-to-day work, please, hit us up on Twitter, comment on the GitHub repos where we have issues for things like this. Just reach out. Your input helps us feed back into the planning process and get those sorts of features prioritized.
So I'm trying to get us up here so that we can see those Twitter handles, because chats was getting cut off, it looked like, and so
yeah. So like
get our Twitter handles up there.
On the previous discussion, like Dustin had kind of a question. which is kind of this path issue. So, I mean, I'm not really interested in the particular answer here. I mean, Dustin might be, but it might be useful to just think about how would you use the log to kind of understand this particular issue, for example.
Sorry, I'm not seeing the.
The question is, on my Mac, I don't have just MSBuild in my path after installing the .NET 6 SDK. If I wanted to replicate this, and by this I assume he means all the commands that you saw earlier, do I need to run every command with .NET MSBuild rather than just MSBuild?
Absolutely. So yes. So I think the bin log may not help with that in particular, but yeah. So I did this to replay using MSBuild. This is MSBuild.exe, which is on my path because this is a developer command prompt. But you can also do .NET MSBuild and that thing, the same idea, and that has all the same capabilities as MSBuild.exe with regard to binary logging.
All right. Well, we have about 5 minutes left before we switch gears. So I want to let Chet and Rainer figure out what they want to share in 5 minutes, as well as Immo. Thank you for keeping an eye on the chat and making sure that we're being responsive to you great folks that joined us today. So thanks for that. I love this notion that magic happens, but it's magic I can go look at. And ultimately, I think that's what this feels like to me, is that when my project file turns into 18,000 lines of stuff, then that's pretty magic. And the fact that I can go look at that magic, I think is pretty important. And I can understand it because, of course, things, MSBuild is a spot people need to keep an eye on from a protect my build point of view, protect my machine, protect things. It can be a security opening if people just start downloading anything out there and running anything out there. Then it is good to understand that this does run in your development environment, and you do want to make sure that you're using reputable packages.
Yeah,
because any package can change MSBuild, right?
Yeah, so that's an excellent point. So in addition to bringing those assembly references, which is kind of the standard NuGet package, right? There's a DLL in it. It gets passed to the compiler. It gets copied to your output directory. You use it at runtime. In addition to that, a NuGet package can contain MSBuild logic and change how the build works. And so if some nefarious actor creates a NuGet package and tricks you into install it, and it has a task that says exec format C, you might be real sad. So you do need to vet your packages on that dimension, as well as the actual code that you're probably already thinking about when you take a new dependency. What are the pros and cons of taking this code? You also need to think about that build logic.
Right. Okay. And
so to that end, I would highly suggest, and this is just a general practice before adding into any dependency, I really suggest looking at that dependency in a viewer like NuGet.info. I don't know if anyone's been to that, but it's another one of this new breed of web-based, WebAssembly deployed .NET utility applications. And this one just lets you really drill into what's in the package you're getting. And so what you can do is sort of look at that package in isolation and look in the build folder and the build multi-targeting folder and see exactly what props and targets it's going to run in your build. Be informed before you add dependencies, right? We've all seen dependency based compromises in the past year in other ecosystems. Let's not have it happen here.
Yep, absolutely. And this, I use this on almost a daily basis to inspect packages, both the ones that I'm producing, the ones that are coming up in kind of bug reports and things like that. And it's super useful. There's also a desktop application equivalent of that if that's more your jam. But the nice thing about this is if you go to nuget.org and search for a package, I will pick my favorite packages, of course. There's a nice link here, open in NuGet Package Explorer, and you can see what all is in that package. It'll download it. It'll open and display it. And you can see in this particular package, there's a lib folder. There's no build folder. And that means that this package doesn't pull in any MSBuild logic. It just has these DLLs. But many packages do have that kind of build logic. So one other thing that you can do, so if you're interested in how exactly does all this NuGet stuff work, you can come and you can say like, okay, I reference newtonsoft.json. Well, I'll search for that, and then I can see it's present in package reference items, and then it's also relevant in different things here, like collect package references, like resolve assembly references, and something here, resolve package assets is an interesting thing. So this is a detail of how does NuGet resolution work, and the answer is package references are passed in, and then output we see package dependencies. Resolve lock file references again is going to come. It's going to add an item, a reference item that points to that the actual correct DLL for this particular part for this particular project to reference.
All right. So I have a question, Rainer, here, because it's like we all know Newtonsoft.json is everywhere, right? So my question is, if this was some other package, something other than Newtonsoft.json, would it also have all these entries, or some of these entries just because Newtonsoft.json is everywhere? I just wonder if it's something special about the fact you picked a package that is one of our most ubiquitous packages throughout the ecosystem.
Yeah, so NuGet has the property that packages can depend on other packages, so you can reference a package that then itself references NuGet.
Okay, so it is, yeah.
References Newtonsoft or something like that. So you may not have Newtonsoft in your project file, and you may get it anyway. In this case, this is happening because in this particular project, I put it directly in the project file. But this is also a great way to see, like, okay, so like in the end, like what is actually going on, and like the bin log will tell you, right?
All right.
One of the things, like we looked at the CSC invocation, you can look here at references. So if you want to know absolutely for sure, for real, what is being referenced in my project, this is what's getting passed to the compiler. So it's what you see. And you see there's a bunch of ASP.NET, a bunch of .NET Core, and then somewhere in here we will also see that Newtonsoft one that we were just looking at here.
All right. So I'm gonna have to cut this off, and so I think it'd be great if you all came back sometime. We'll give it a couple months as you come back and see what you have new for us. Because one thing we didn't talk about is what we can look forward to in the .NET 7 wave coming next fall, and so we didn't get a chance to talk about that. But we are cutting this short because we really want to cover this language feature. So I'd like to thank you all very much for being here today. It's been so much fun. And of course, you're some of my favorite people. So it's always good to spend some time with you. And I look forward to when we can talk again. But right now, I'm going to boot you out. I'm going to bring in Jared, and we're gonna have a chat about something different here. So I'd like to say goodbye. Thanks again.
Thanks for watching.
Hello, Jared.
Hey, how you guys doing?
We're just doing this big reset. It's going to be a little bit of a whiplash for folks. And so we're doing this because there's been a lot of talk on Twitter about one language feature that's being introduced. Yeah. And the thing that you said you wanted to share was, folks, we did think about this. And, we worked pretty hard on it. So can you talk about what the feature is? And then maybe if anybody... Sure. A link to one of the Twitter streams.
Yeah.
And then
we got a couple of that.
Yeah, just tell us where we're at, and we might go over by a couple of minutes. But yeah, let's explain this thing.
All right, let me go ahead and share something out here. Let me see if I got the right one. There we go.
All right, let's go.
All right, is that popping up for you all? You seeing? There we go. Look at that.
You're seeing it. Yeah, let me go ahead and make that full screen so everybody can see it just a little bit better.
Right. Okay. So using lovely Sharp Lab to demo here. So first off, we
could you zoom in a little bit?
Can I? Let's see.
Control plus.
There we go.
Here we go.
All right. So on Twitter the other day, someone started retweeting some feature changes that we were testing out in the Runtime repo, and it caused a lot of discussion on one of these potential features we're adding to C# 11. And so first of all, I thought the first thing to kind of talk about is, what is the feature? Like, what are we actually attempting to ship here in C# 11, and kind of talk a little bit about how this is working its way through the system. So the core feature that we've been shipping, that we're looking at shipping, is removing the ceremony around argument validation. So the most common argument validation in .NET is null checking arguments. And you can see, like, we have the nice syntax here where we have an add method where it's for a map, has a key and a value, and generally maps don't allow null keys. So we have the key equals null, throw argument null exception. The problem with this is, like, it's verbose. And this is something that .NET developers have been writing since the beginning of time. And it also has a couple other downsides. It's actually not the best way to, it's not the most efficient way to do argument checking. When you have throws in methods, it tends to impact decisions like JIT inlining. And there are kind of more efficient ways to represent this. And there have been requests pretty much since the inception of C# to make this simpler, make it more automatic. Please give us a syntax for it. Like, there are examples going all the way back to C#. There are experiments with code contracts to do this. And it recently came up again when we were initially doing nullable reference types. We started revisiting it. And about that time, about 3-4 years ago, we actually sat down and said, okay, let's think about a syntax for this, and let's actually attempt to do a feature. And this work started about 3 years ago. It originally started with a couple interns on our team. We've had 2 different interns work on it. And recently we had an FTE who kind of decided to finish it off and get it merged in. And the syntax is simply just removing all of the ceremony and then just adding bang bang to the end of the parameter name. And you'll see here on SharpLab in just a second that the, whoops, well, it looks like I have confused SharpLab. Let's hope a quick refresh fixes that. Oh, it's because I have the wrong branch. I'm sorry. Have to be on the main branch. Yeah. So you can see here, we run this code, and now we have essentially the compiler has inserted a null check for me, has to throw up null key. It's going to generate the same code it did before, except in a slightly more efficient way that'll support items like better JIT inlining. And like I said, this is a feature we've been working on. We are currently shipping this in preview. So we added the ability to ship preview features in the language a couple of years ago. And that's had a lot of advantages for us. It means that if you kind of go back to the old C# model, we released every few years. We kind of dumped features on customers pretty late in the game, and there was very little opportunity for feedback and getting customer input on the decisions we made, potentially any syntax problems that we were thinking about. Whereas now we've actually added a lot of infrastructure into Visual Studio, into the way we do the compiler, where we can start shipping features well before we believe they're done, so that customers can start giving us feedback on them. And that's what we've done here. This feature is going to be coming out in 17.1 of Visual Studio, and which is roughly probably about like 9 months or so before C# 11 RTMs with .NET 7. And yeah, and so this is something we wanted to kind of get out early, get some feedback on, because we knew the syntax would be something that people focused on a lot, because we spent a ton of time in language design debating like which syntax we should or should not use for this feature. And the decision was ship it in preview, let customers see it, let's give some feedback, and we can tweak it, figure out the best way to kind of make this palatable for everyone. Now, so that's kind of the general feature and what it provides and why we did it. But I want to, and this obviously raised a lot of kind of feedback with the community, and I kind of want to address some of that now. So like the first bit of feedback was like, this is a really strange way to announce a feature. And the thing is, we weren't actually trying to announce the feature yet. Like I said, we've been working on this for 4 years. We've been talking about this in language design. We've had lots of language design notes on the decisions we made, the kind of scenarios we were considering. And those have been posted in a lot of different places now. And I can drop some links in the chat if people are interested. So this is not something that we just like suddenly came out of the blue. We've been working on this for a long time. What happened was, as with most big language features, what we do is the first thing we do is we try them on our own code before we ship them. Because one of the big advantages we have is we have the .NET Runtime repo. We have the Visual Studio repository. We have the C# compiler. We have a lot of big code bases that we can test our features out on and see, like, do they work in prime time? Do they work at the scale? And particularly what we've done in the runtime repo is we both wanted to validate that the feature was working and producing the right code at scale. And two, we had written a fixer in Visual Studio that allowed customers to kind of have a nice global switch to say, take all my code, which does the if, null argument checking today, and switch it to the new syntax. And we effectively have been, for the last month or so, iterating on that feature. We've been opening up the .NET runtime repo. We've been running that fixer, just seeing like, did it work? And we actually got to a point recently where it worked, and Stephen Tobe felt comfortable. He went ahead and pushed the PR all the way through, made sure we got all the validation, all the tests were running, and we recorded it. And people started picking up on that PR, and they're like, it's like, yeah, that was not intended to be our announcement. That's just our kind of standard pattern of, hey, when we have a new feature, we like to test it at scale, and we want to see how it works. This is coming out in 17.1, where we probably would have talked a little more about it. But yeah, so it wasn't meant to be an announcement. It was just us doing what we normally do. If you look back through the history, you can see the compiler team sending many PRs to the runtime repo over the years where we were testing out new features, things we were worried could be breaking changes, and just validating that they essentially exist at scale. So kind of the next set of feedback we got was, oh my God, like this syntax choice, like why did you make this syntax choice? Like that was one of the most, common pieces of feedback. Like there's a lot of feedback of why did you put like, the double bang on the parameter versus the type? And there were a number of scenarios we were thinking about when we did this feature. The original version, I think the original proposal for this feature had a single bang on the type name. After a lot of discussion, though, the language team felt that this was talking about values. This was not talking about types, and they wanted the syntax to be on the value. And the reason we went with a double bang originally versus a single bang is that the language team was considering that this syntax might not be only useful in parameters. There were a number of scenarios people brought up in the discussion on, I want to use this in the middle of my code. I don't want to get a value back and say like, okay, I'm going to call a method, get a value back and say, if this is null, go throw our null exception. I want to have the same syntax that works at the parameter level, that works inside my code. And I want to make that happen. And unfortunately, like a single bang is already legal. So you can do like a bang in your code today, and that's just fine because that's actually the null suppression operator. And so the reason we went with a double bang is because it is not legal expression syntax today. It's something that we can potentially expand the feature out into in the future. Now, I mean, and it's easy to say, particularly if you look at the notes, like this syntax was not like, didn't have people jumping up in the room saying, this is perfect, we have found the solution, this is great. It was actually the opposite. In some ways, we felt like this is the syntax we found that worked. And like I said, one of the reasons we put this out here is because we wanted to give it to customers. And we wanted to say like, hey, this is what we're thinking about. Help us find the better syntax if you think that this one's not going to work. Like I said, one of the reasons we went for the double bang versus a single bang was the idea that customers might want us to push the exact same thing into method bodies. If the universal feedback is that's a terrible idea and we never want to do that, why would you we would rather have the simpler syntax and forego that method body syntax, then that's good feedback for us to get that can help us make decisions on what the final thing looks like. And we're, like I said, this is why we put the features out there early, so we want to get the feedback on them.
So Jared, that is fantastic overview. Thanks. I do have one question, which is, what about attributes? What was the reason that is attributes just too wordy, or was there more reason than that?
There's kind of two reasons we went away from attributes were kind of not considered. The first one was, yeah, they're a bit wordy, and no matter what we found, like we had like throw null, we had a bunch of others. People felt like it's getting a little wordy. It's changing things. It's also it violates a subtle principle of the language where attributes don't affect behavior in the language today. Like you can put all these attributes on your code, and they are virtually meaningless to C#. There's basically about 3 or 4 attributes out there that actually impact C#, and they don't change the behavior of the language. They just change whether or not you get an error. Like DLL import can give you an error if you don't do static extern. Obsolete can give you an error or a warning depending on their situations, but they don't change behavior. They just change whether or not your code compiles.
It's a super interesting point because it'll be interesting to see as we go more into the generative world and we have some more things that we're doing with generation like this, whether or not that holds up, because ultimately that's what's happening here, right? Is that the double bang is just causing generation to happen behind the scenes that results in almost exactly the same code. You said it was better. that the code I would write isn't the best way to do this. So we're generating the best way to do it.
Exactly. And like I said, it's not that the language is like, we will never change behavior based on attributes. It's we've never done that so far. And that's when we cross when you cross a line like that, you do need to be careful and thoughtful. So there were a couple other pieces of feedback that we got, particularly in kind of like the C# Lang discussion that I wanted to talk about. Like one of them was there was a lot of feeling like, why didn't you guys tie this to nullable reference types? Like, after all, you did all this work to like null checking in the code and give us null visibility. Why didn't you tie this feature to nullable reference types? And let me be clear, that's a very like sensible way to see this. Like, why did you do that? Like, again, the reason we started looking at this feature again is because when we were discussing nullable reference types, we said, well, crap, it would be nice if we had this better syntax to make this easier. And it kind of spawned off a side discussion that evolved into this feature. So the reason why is like one thing I think customers have to understand is like adopting nullable reference types is not a trivial thing. Particularly for larger like code bases that have been around for a significant amount of time. I mean, if you look at like the C# compiler, we care a lot. I'm the C# compiler lead. We care a lot about nullable reference types. We put a lot of time into making them work. The compiler is not fully null annotated. It's millions of lines of code. Like annotations is a very thoughtful decision you have to go through. If you've watched any of the work Stephen Tobe has done, if you get any of the PRs into Roslyn, there's significant back and forth on like, is this the right place to put the null? Should we change our behaviors to make these annotations better? It's a very thoughtful process. And the end result is, if you look at like how many customers have nullable reference types enabled versus how many customers do arg null validation, it's orders of magnitude more have null argument validation. Pretty much every .NET customer does argument validation. Not nearly as many do nullable reference types. And so if we tie these two features together, we're basically telling customers like, hey, you can't get this better, you can't get this more concise syntax and the better code gen until you go through the man years of work to push this through your gigantic code base. And the other reason is you can't, like I said, we're talking about how do we adapt existing code bases to new features. You can't run a fixer for nullable reference types because, again, it's a thoughtful thing. There are a lot of fixers out there that kind of do a best effort annotation. They're like, hey, we can look at your code and we can make some pretty quick inferences on what's going on here, and we can do some pretty quick, high hit count, like high hit percentage annotations, but they will not be perfect. On the other hand, with the fixers for argument null validation, that's pretty easy to find. Like, it's look for all the if nulls at the start of the method. If they match up to a parameter and there's nothing in between, then you just flip it to the new syntax. Writing a fixer for that and a feature where we can take these existing code bases and just mass move them to new syntaxes, it's very approachable, and we did it. And that PR in the .NET Runtime is a great example of a gigantic code base where we were able to run that fixer and have a very, very high percentage of success there. There were a number of scenarios where they had some very specific legacy concerns. They had to be a little bit careful about their annotation, but that was by large and far an extremely successful mass migration. And it also gives us confidence that customers can adopt this very easily as well. Now, and like I said, so the other one that kind of came up, and this was somewhat related to nullable reference types, that's kind of evolved with that discussion of why not just have a global switch then? Like, why do I have to go and take all these parameters and say like, hey, this is a public parameter. Like I should be doing argument null checking. Like, do it for me, compiler. Like, why do I have to put a switch here? And I think that I understand, like, once again, I understand the intuition. This came up during language design. If you read through our notes, you can find some discussion on it. And I put a little bit in the kind of C# Lang discussion about this. But overall, I think it's kind of the core of the problem there is it's a bit of a disproportionate response. Yes, like nullable reference types has made it like much clearer. You can look at a perfectly annotated code base and be like, oh my God, like I know that this is never null. Like I have it enabled everywhere and it's great. The problem is like the vast majority of parameters in .NET are non-null, and the minority have argument validation against them. The vast minority. I mean, if you can just look at any code base, even the .NET code, the .NET Runtime code base, who probably has some of the strictest null argument validation of any code base out there, the minority of their parameters have null checking on them by a large and far. And the reason why is because if nulls is like you're adding both code bloat, you're adding conditional branches into your code, you're impacting performance. And so argument validation is pragmatic. It is a pragmatic choice that people make. Having a global switch is going to negatively impact that. I mean, for instance, like there is even no universal agreement on what should we be validating. Like often one thing that people have like said to me before is essentially, hey, okay, it's great. Like just do public parameters, just do public. But like even like what's a public parameter is not that clear. Like, can you put my screen back up again?
I
Like
can.
the code screen?
Yeah. You want us there with you? It's blank. It's not very interesting. Okay, let me get rid of us. There you go.
So like one example here, like let's just take this object key example here. Like once again, this code has nullable reference types enabled. I have a non-null key and a nullable key, a nullable value. Like, should we be adding? Is this key parameter public? I mean, it's not a public method, but it's inside of an internal type. So is that public or is that not public? I mean, also consider that I think a lot of people would say like, well, maybe that's not public because it's an internal method. But then what if this is a type for which there is an internals visible to another assembly? If we have IVT in the assembly, should we do this? But also consider like in this example, even though this is a public method on an internal type, so effectively like this is internal, this also implements an interface member. And this interface member is public, which means that from the perspective of IMAP, this is a public method. So should we be adding, is this public or is this not public? And the problem is like this discussion, no matter what heuristic you choose, like if you say, I want public, I want this, I want that, there's generally no good agreement on what it is. And also compilers are ruthless. Like when you make a decision, like we want it to be public parameters, compilers like, I got you. We will do it for every public parameter. And when I've been involved in features like that in the past, and people look at the code gen the compiler does, they end up very surprised at what was actually public in the repo and what was not public in the repo. It's a very, I've had many discussions before, like back in like the code contract days, where people are like, you need to add these before, pre and post conditions. I'm like, yeah, let's look at this like one statement. Do you know how many method calls you make in that statement? Like how many pre and post condition checks I have to omit? It's astounding when you get to like the ruthless level at which a compiler is going to enforce things.
Yeah.
And that's one I was kind of tell people, it's like the global option is very hard. Like, where do you do it? It's not as clear as I think people believe when they really start getting into the details. So the other problem is a global switch also, any type of global switch that you add to a compiler that has semantic behavior, that changes the behavior of your program, it starts to reduce code readability significantly. Because for instance, like you look at this code, like no matter what heuristic we add, like let's say we did the public. If you are a public parameter, which means that you are on a public method on a public type or an interface member, we will generate the check. Well, let's just look at this code in abstract. Like when I just look at this line of code, how do I know if it's going to be generating a null check or not? I have to identify a bunch of different things. I have to say like, okay, well, what interfaces does this implement? Is the type that I'm in public? Is the method I'm in public? Is there a global switch? Like, is that in my project? I have to go look at the project file to see if that switch is enabled. Do I have to go, oh, it's not in the project file, but maybe someone put it in the directory builds props file. It just makes code harder to read because you have to have this outside context to understand how it works. And that's also one of the reasons why, like when we talked about nullable reference types, we designed it specifically to not impact semantic behavior. We wanted to say that, yes, the global switches does make it harder to understand if nullable is or is not enabled in your code base. But the annotations don't affect how your program behaves. So we're a little more comfortable with that. You can have all the annotations you want and your program will execute the same. It will just change the warnings that you get.
So,
and I would say the last bit, like why a global switch, is kind of problematic, is it doesn't work for every case. It just doesn't. If you go and I, as a concrete example, go look at the runtime PR that Steve and Toe put up where they add this feature. Go look at the discussion that they had on a lot of things. There are many places people are like, hey, we want to do it here. And Steve and Toe's like, no, we're not going to do that because this is actually like, he pulled out like, think about how this code works. Think about these values. The feature doesn't work in this context because of very specific constraints in the runtime. And so the idea of like having a global switch, like I understand why it's attractive, but when you look at it in practice and in details, it means it kind of is unusable in a lot of contexts. Like the runtime team would not have adopted the feature if we had done that because it impragmatic unless we also then said, here's an opt-out switch too. So we're going to give you the global switch and we're going to give you the opt-out syntax. But yeah, so this is kind of like why a global switch is something that we are very reluctant to do, and we felt it was the wrong decision for the future.
All right, so obviously you have thought an absolute ton about this, and I'm thrilled. It's so great to work with you. So what I want to do is I'm going to put up a banner here that has one of the places that this conversation happens. So you mentioned a couple of things in here I just want to briefly touch on. You mentioned the LDM. If you go back in these shows, you're going to see one we did with Mads that talks about what the LDM is and how it works. Short answer is it stands for Language Design Meeting. What it is a group of people who are tasked with keeping C# moving forward in the way that benefits users. And so that's the group that worked on this. That's the group that that focused on the feature in this case. And then we also focused on the syntax. And I think it's valuable here to look at how the feature works is a little separate from the syntax. But if you have a better idea on syntax, I'd love to hear it. If you think we're wrong on attributes, I'd love to hear it. I mean, we all would. I mean, that's just not me. I mean, I'm saying we all would love to hear it. This is one of the places that we can have this conversation. Also, you can look at language design meeting notes. The language design meeting, for many good reasons, is not open. We have interesting discussions sometimes. But we do have very good notes that are created with folks that are very dedicated to doing that. So you can go back and look at the language design notes. So with that, I think I'm going to pull back in Rainer and Chet so that we can all say goodbye. We'll be crowded here for a minute. All of us are going to be crowded and small. But Immo, do you want to take us out today?
Yeah, I just wanted to add my 2 cents because the discussion on Twitter is interesting on this language design. And as you said, people should kind of I mean, I appreciate feedback like everybody, but what makes me sometimes a bit tired is when people spend 30 seconds thinking about something and then they think they know everything about it. And we are just idiots for not doing the obvious thing. And that's a fine reaction. But the reality is that, as Jared explained, there are reasons why we discussed them and rejected them, right? So I think we appreciate feedback, but I would also say, if you want to be more helpful in the conversation, read the arguments against it, and then try to kind of frame the discussion in a way where you react to the reasons rather than just saying, "Oh, I don't like it," because some of the stuff is language design. There is, of course, fashion and taste involved as well, and there's no objectively wrong or right answer, right? And as Kathleen said, there's a reason why there's a bunch of people involved that try to preserve the spirit of C#, and that sometimes comes with certain evaluations or I guess decisions that are not always popular, but that's what we feel is best for the product. But yeah, there's lots of stuff that can go on, and I think it's an interesting conversation.
Yeah, I think that people sometimes don't understand how big the room is when we go through language design and how many. I assure you that whenever we make a syntax choice, there has never been a meeting where someone says, this is the syntax, and everyone said, great job, we all agree. That has literally never happened, ever. And oftentimes language design devolves into, let's ignore the syntax for a minute. Let's talk about the behavior. We all agree how the behavior works. Now, bite shed time. And then I leave the room and let people argue about the syntax. So it definitely, syntax is something that is always the most controversial. So it is always, and like I said, and we knew that this was not going to be the most straightforward one out there, and which is why we put this out in preview, because we want to get feedback. Like I said, there are specific choices we made based on assumptions that we want to get validation on.
Yeah. And we all go in the room and we all share our opinions, and then we all come out and we back what we decided, so that we can get your opinion and focus on that rather than who thought what on this particular feature on the way we get to this point. And actually, that's a big reason why it's not public. So this is a feature that we all believe in, and there was a feature, I don't know, 10 years ago, there was this feature that you now know is private protected that we wanted, and it sat as a non-feature for release after release after release because it couldn't be named. There was the most massive naming exercise ever performed, and the only thing that it proved statistically is that whatever was chosen, somebody would hate it a lot. And so at that point, private protected, which of course is in perfect syntax for a feature that was present in .NET from the very inception in 2001, 2002. So yeah, so it's in language design, it's an interesting effort. This is one that we believe in the future. We also really want feedback on the way the feature works. I think we have a really good case for it not being global. I feel, pretty, yeah, we really we'll keep listening on that one, but we think that it would hurt more than you think it would. And yeah, so yeah, and that's why we did it. We learned that from doing it across the the runtime BCL work. That's why we did it quietly there. It wasn't anything else other than we need these people's feedback, and we'll respond to it. And they liked the feature a lot. What was it? Steven said 15,000 lines of code or something. That they dropped. It was
17, I think.
Yeah. There is a similar like gigantic change that we have not yet done this in the Roslyn code base, but we dog fooded the fixer a number of times, and so I've seen the previews, the kind of private drafts that we had playing with it, and it's a significant amount of code that we can delete.
Are we going to pick up a little performance in that? Is it going to improve performance a bit?
Subtle, because one of the things, and this is something I casually mentioned, and it gets into the details, like the way that most people write, like if throw, like it's actually not the best syntax. If you go and look at the runtime repository, they actually very often do not use if throw. They actually do if argument dot throw, and it's because pushing the throw to another method impacts inlining decisions and things like that. 99% of the time, it doesn't matter. Like most of your outer methods, it's more tight loop validation. But when you get to the level of runtime, like they care about that kind of thing. They care deeply about that, and they will go the extra mile. And now, though, everyone gets it for free. And we actually worked at the very specific code that we generate. Like a lot of discussion was with the runtime team on what do you want us to generate that you all feel like you can optimize the best. That is going to be produce the most sharing, produce the best JIT. And so it was a significant amount of time working with them on the exact code that we generate. And it's possible we might change it again slightly before RTM just because they think they might be able to generate a little bit better if we flip it around slightly.
Yeah, the other thing I would say, like private protected is also a perfect example of something.
It's a great example.
Lots of people had strong opinions, but since it's shipped, I have not heard a single complaint about the shape yet. So I feel like it might be the same here. People hate it initially, and then when they use it, they're actually fine with it. But also because the way the feature is designed, arguably in the future, if we change our mind and want to make it a global thing, we can still do, because that's easier than removing a global switch that we hate, right? So I think there is people also forget sometimes that things evolve over time, right? Just because we make a decision today doesn't mean we're stuck with that forever necessarily, right? And some of the things we actually have to use to actually have an opinion on, right? Just whiteboarding doesn't only go so far too. So
there's one last question that I thought you might be able to answer pretty quick, Jared. We're going way over, but we'll do this and then I'll let.
Yeah, and so I think that's. I'm glad. Sorry, I would try to respond to some of your comments in the chat, but for some reason I can't comment in the chat. I've tried a couple times. And
I know why.
I failed. But no, I'm glad you brought that one up. So I'm gonna say so this is something I actually disagree with, because this gets back to my thing that the point I said earlier. If you look at parameters, like which ones have argument validation and which ones don't, the minority of parameters have argument validation on them. And that's just, it doesn't matter how you look at it, like which code basis you look at. Generally, argument validation tends to be on the kind of public surface area of a library and API. When you get into the internals, argument validation starts disappearing dramatically. When you get into the private methods, it's pretty much non-existent. Like argument validation on private methods is virtually non-existent at mass and scale of like the .NET, how .NET is generally written. So when you kind of look at this code base, so when you look at .NET as a whole, the majority of parameters will not have one of these two annotations. The majority of parameters will likely have nothing or the question marks on them. Now, if you rephrase it slightly and said that essentially all parameters and public methods have one of these others, I would say, yeah, that's probably true at that point. That is that is closer to the end game that is going to happen there. That is true. But as for overall parameters, I don't believe that's the case. And there's just lots and lots of code that you can look at to say that argument validation is a minority compared to overall parameter use in .NET.
All right. Well, we're way over. Immo, you want to take us out here?
Yeah, I mean, I think this was fun. I think we went over time, but I think it was warranted, and I thank everybody for the good discussion. We had great questions in common, and yeah, questions in the comments, which is always great to see. And then we should definitely have Rainer and Chet on again to talk more about MSBuild, because people clearly care, and we don't talk about it enough, I guess.
And Jared's back to talk about the compiler.
Oh, yay.
All
All
right.
the evil things I've seen over the years.
All right. Bye,
Rainer
everybody.
has seen worse.
Bye-bye.
We send each other things.
Yes. Bye, everyone.